And hello everyone. Welcome to another stream on Freaky Physics, and we're gonna have a lesson today. I'm actually a bit late, so I'm going to just get right in. And let's enter the classroom. hmm Is it just me or am I? That's okay either way. Here we go. Let's open the problems for today. Let's wait. And ah, huh? Let's also open all the apps I need today. All right.
Hello.
Hello, Gita, and good afternoon. hmm How's
Good afternoon.
how
I'm
are
sorry
you?
again for yesterday.
Yeah, I'm just wondering about that. What
Um,
happened?
well, I checked for Monday, but I didn't check for the rest of the week, and then I
Ah,
forgot to tell you that I can't come because for the whole week I've been staying in school till about 6 p.m. because I have a lot to do.
all right, no
So
problem. You think it's
I'm
gonna happen
sorry.
again next week? Is
Yeah.
you think it's gonna? Yeah.
I'll have to reschedule because I can't do it over the week anymore,
All right. So
especially
okay.
because I have applications.
All right. So what you could do here is okay for January. I think I can reschedule everything. No problem. Just let me know which days you're available. But
Okay.
for starting from February, I think it's gonna be best um if you what's the term here? Not really cancel, but if you reschedule your lessons yourself because yeah, because everything's automatically booked at the moment. So that's why we're having these issues.
Okay.
Yeah. So
Yeah.
yeah, I think the best thing to do at this point from now, not from now, but from February is for you to schedule everything so it's easier on both of
Okay.
us. Okay.
Yeah.
All right. So, all right. I've just opened everything. Oh, by the way, you still, I think you still want to get those the lesson yesterday rescheduled as well, right?
Well, I thought that I we lost the lesson, and I kind of accepted the fact because it was my fault.
All right. Yeah,
But
well, I'm still okay with it, just so you know. But if you really want to do that, then it's fine with me as well. Yeah. So, okay.
okay.
All right. So, all right. So let's just get started here. Oh, okay. We're doing space.
Yes, we started in school, but some of the questions are math and
Yep.
some of the questions are not there, but I
Mm-hmm.
have them written down.
All right. Let me see which ones are math. You have two math questions here.
Yeah.
All right. Let's start with this thing. Okay. I recall last week I kind of introduced you to a bit of. Oh no, that wasn't you. That was a different student.
Mm.
I kind of introduced this idea to the student about what's this? Calculus. And
Oh,
that's exactly the thing I'm looking at right now. Okay, so this
yeah.
requires calculus, right? However,
Yes.
okay, while I'm setting this up, quick story. You know who invented calculus?
No.
It was Newton. It was Isaac Newton.
Oh.
And you know why he invented calculus?
No.
Okay, he invented calculus because the math that he needed wasn't invented yet. So he invented the math he needed to do the
Oh my
physics.
God.
Yeah, uh
Smart.
that's how smart is not enough to cover that. Okay. All
Yeah.
right. So anyway, here's I won't go to the details. Let's go straight to the problem here. Yeah. Oh, I haven't
Yeah.
shared my screen yet, have I? Let me share that first.
No.
All right.
Mm.
Right, here we go. And I'll share that on the stream as well. Where is it? Where is it? Here we go. All right. So here's the problem, and you see that in this particular case, you're given the velocity equation, right? So let's recap this real quick. So again, we know in terms of calculus that we can do this two ways. That the velocity could be equal to the derivative of the position over time. Okay? Or we can also say that the velocity is equal to the integral of the acceleration over some time. Yeah? All right. Now,
Yep.
just for completion, let's do the others. Now, what else is here? We have the acceleration is equal to dv over dt, and that's equal to d squared x over dt squared. Okay. Um, we have the other one. That's not, it's not gonna be an or. Now we have x. Now that will be the integral of v dt. Okay, so in this case, which one do we need? We will definitely need um this in our problems. Okay, now part A is pretty straightforward. So let's go to A. Part A is pretty straightforward. Just substitute t equals 2 for all the t's in there, right? So v at 2, not 12. V at 2 should be equal to 1 plus e raised to negative 2 minus e raised to negative sine of 4, right?
Yep.
Okay. Yeah, that's it basically, right? Um okay. So what is the sine of 4? That's the weird thing here, because if this were an angle, definitely that's not going to work. But of course, if this were an angle in degrees, right? But remember that this should be, when you work with this should be in radians.
Wait, sorry, I have a question.
Okay, go ahead.
Because this was a non-calculator paper, how
Mm-hmm.
would we simplify A?
Okay, that is a very good question. You don't.
Hmm.
That's
We just
already,
leave it that way.
yeah, because this is a math problem, right? If this were a physics
Yeah.
problem, we would put this in a calculator and everything. We can still kind of simplify this to turn it into, we only have one term with e on it, right? So that's gonna be 1 plus e. I think that's it, because can we simplify this? Actually, yeah, we cannot, because this is being subtracted. In fact, because of that's being subtracted, that's it. We can't factor out the e, right? So this is already the answer.
Okay.
Okay. So as
All
you
right.
said, if it's non-calculator, that's it. You just have to indicate probably this, that's in radians. Okay. All right. Let's go to B. Find the maximum velocity of the particle. Okay. In terms of, let's do the math behind it first. So remember that V is a local maximum or minimum. Local maximum or minimum if dv over dt equals 0. Okay. Um, okay, that's how it looks like in mathematics, but in terms of the physics of it, just to cover it a little bit, in terms of the physics of it, remember that the acceleration, basically, if there's acceleration, the velocity should change, right? When the
Yeah.
velocity doesn't change anymore, that means the acceleration has turned to 0. So when the acceleration is 0, that's when you have your maximum or minimum possible velocity as well. Okay. All right. So going back to this and actually just solving this now, we're just gonna equate this whole thing to 0, right? Okay. Find the maximum of in this case. So our so let's do this now. dv over dt. What just happened there? Over dt. is equal to, well, let's just do this. Derivative of, let's go back to the equation to make it easier to see. Okay, that will be the derivative of 1. That will be 0, right? Plus the derivative of e raised to minus t. That's going to be e raised to minus t, but there's a negative sign here, right? And then finally, we have minus e. This one's the tricky one. This is going to be equal to, I'm going to put some space here first. E negative sine 2t. Okay. And the derivative of sine 2t will be sine. Okay, this will be cosine. So negative cosine of 2t. Okay. Now, because of that, there's also going to be a 1/2 here. Okay, so there's a negative 1/2. So if we put this all, rather, if we simplify this now, we're going to get, that's going to be, this is a double negative, so we start with this. 1/2 cosine, 1/2 cosine of 2t, e raised to negative sine 2t minus e raised to negative t. Okay. Now, of course, because this is now, we're looking for a local minimum or a maximum, then we're going to equate this to 0. So we'll put that here, and that's going to be equal to that. So we now find the value of t. All right. Is that what we're looking for now? Find the maximum velocity. Okay. So once we find t, the idea here is we're going to find t, and then we're going to plug it into the value, into the formula for v. Okay. So in other words, this becomes, let's just further do this. This becomes e to the minus t is equal to 1/2 cosine of 2t e raised to minus sine 2t. When will that be? Okay, when will this be 0? When will this be equal to each other? This is gonna be tricky. Okay.
Actually, I
Yeah.
think I got it wrong. I think this is actually a calculator paper, so we could plot it.
Okay. Yeah, I think, yeah, this should be a calculator paper from the way it looks like. All right. So anyway, if this is a calculator paper, then what you can do is just plot this straight away. Okay. Plot this straight away into your into your calculator, and then find t, right? Okay.
Yeah.
I don't have a calculator here with me that could do that, so I'm just gonna open a website here. I will open Desmos. Okay. Okay. Quick, say hi. I know you want to say hi. Quick. Oh, you have a question. Show the camera. Oh, there we go. Wait a moment. Here. Say hi.
Hi.
Alright, say bye-bye now.
There is still one more drawer.
Muti. No.
Hi.
Alright.
Bye, see you next year.
Alright. So, okay, going back. So where were we? I was going to Desmos to plot this. Have you... Okay, there we go. Let's just put the formula in. E raised to negative t. Negative t equals 1/2 cosine of 2t. Oops, the one, let me put that then. Cosine of 2t. Then e raised to negative sine of 2t. Oh, sorry, yeah, that's gonna be it. Let's change that to x. Okay. Okay. So if you put this in the calculator, I'll share my screen in a while. Okay. Okay. This is okay. So this is what we get. Okay. Hold on. Let me just copy the screenshot here. It's gonna be easier, right? There we go. All right. I'm gonna say this much though. This looks weird, so I think we may have done something wrong. But this is the graph I got. It's just a bunch of straight lines.
Oh. How could that be if it's cosine?
Yeah, because I think it's because of the e raised to sine 2t that's a problem here. Okay. Okay. So since that's the graph I get, this pretty much means I need to redo something here. All right. But okay. Let's take a look here. Well, what's the first value of x that we get for maximum velocity?
I can do it.
Okay. I really find this weird.
E-
Okay, go ahead. We'll wait for what you get. I'll just analyze what we've done so far.
Mhm.
All right, so that's correct. We took the
So,
derivative.
when t is 2, we get that v is minus 5.117 times 10 to the minus 3.
Okay. So we get this again. Say that again, please. The time we get is
Minus 5.117 times 10 to the minus 3.
okay. All right. Now, whatever value of time we get here, whether this is correct or not, it doesn't matter later on. Okay, because what happens is we need to do the next step. So if you can't find the correct time, that's fine. You'll probably get penalized 1 or 2 points. But let's say that this problem is how many points? 2 marks,
I
right?
think 6.
Okay.
Oh,
This
yeah.
whole thing is 6. So once you find this time, you just put it back into the formula. V of t is equal to 1 minus e raised to minus t plus e raised to negative sine 2t, right? You just put this value of t back into there and find the velocity.
Okay.
All right. So again, I want to double check the actual value later, but either way, you're putting it there in these here. Okay.
Yeah.
All right. Let's go to the last one. Now, what's the last question here? Find the acceleration of the particle the instant it changes direction.
I guess we need a graph for that.
The instant it changes direction. Hold on, let me double check what that means. Okay. Mathematically, that means we're looking at, well, this is weird, honestly, because actually, the mark distribution for me is weird. Because I feel like the idea here is you already know the acceleration when it changes direction. We just talked about it. When it changes direction, the acceleration must be 0.
Yeah.
Okay. So I really think the mark distribution here is a bit weird, but okay. Okay.
Yeah, when I plot the graph, I also get it like one single straight line.
Mm-hmm.
So
All right. So let's just put it here in part 3. Okay. Um the idea again is when A equals 0, V equals maximum, right?
yeah.
Or minimum. Okay. So that means if you kind of graph this, this is V and then this is T. What you're going to get basically is if you have this kind of graph, that's your max this is your V max, for example, right? And we know that that's a turning point, inflection point, right?
Yeah.
Okay. And when you have an inflection point, what does it mean? Okay. And then when you get an inflection point, that basically means what? It's turning, right? So there's
Right.
turning. So in other words, the reason why I find the mark distribution a bit strange here is because in order for you to do B, you need to find the acceleration anyway, right? In
Yeah.
order for you to do C, all you have to do is interpret this, what you did in B, to be the acceleration.
But I sent you a picture of a graph. I actually got to
Aha.
plot it on my GDP.
Okay,
And
good.
but for which because those does a lot of curves.
Oh,
So
right.
which
Well,
point would you use?
you have to look in the given information. It has to be just between the times 0 and 2.
Uh-huh.
So,
So that's x
yeah.
axis.
So that's on the x-axis. So if I okay, let me just copy just a graph that you have. You have to look into the graph and just limit yourself to the y-axis and x equals 2. Okay.
Yeah. It's a very small portion of it then.
Mm-hmm. Yeah. So I'm going to assume if I let me post the image you have here. I think your graph is better, so we'll use this. Yeah.
Yeah.
Okay. It's taking its time to load. Hold on. Just so we're clear, this is a velocity time graph, right?
Yeah.
Okay. If this is your velocity time graph, then you can already see where the acceleration is 0. Mach is 0. It's gonna be right here and here, and then we have here, and then we have it here, right?
Yeah.
And then I'm going to guess that if you excuse me, I'm going to guess that if you do this, if you zoom into this, that this is gonna be our time equals 2, more or less.
I sent another picture.
Oh, okay. Let me see that other picture now.
Sorry.
Yeah, sorry, didn't see it.
Yeah. Mhm.
And this other picture
It's for
is
time equals to. Yeah.
okay. Great. Okay. Yeah, basically this is it. So let's just copy that as well. Hold on. This is strange. All right, here we go. Excuse me. Um. Okay, you already limited yourself. Oh, anyway, yeah, you already said it here. X equals 2.05, so you're pretty close, right?
Mhm.
All right. So in this case, all right. Okay. So in this case, all you have to do now is really just get the value of the acceleration from here at whatever those times of maximum and minimum velocities are. Okay.
Mhm.
All right. So just do that. And okay, unfortunately I can't really read the graph clearly here because there are no marks for the number, so you have
Yeah.
to look at it in your calculator and see what the actual value is. Okay.
Hmm.
All right. So okay, is this clear at least, or at least you're getting the idea how to do it?
Yeah, more or less.
More or less. All right. Hopefully okay, I think I really should buy a calculator so I can get used to it. All right. So let's just go now to the second problem you have. The second math problem you have here is this. Let's put it up. Mm-hmm. Okay, so you're given another function, um, and we're looking for the period of. This is a periodic function because of the nature that it's got
Okay.
the sine function in it, right?
Mhm.
Okay, so you're given these. Find the period. Okay, all you have to do now. This actually relates into physics again. Okay, but okay, so and then this omega here is the angular frequency. Okay, and we know in physics that the angular frequency is equal to 2 pi times f. Yeah, so in other words, once you find your omega, you can find your f. And then this thing is
Right.
the phase difference. You see these terms, they all came up in physics. This is actually the equation, the full equation we can use to describe it.
Mhm.
Okay, all right, or phase shift. Let's just do it shift here. Okay, so anyway, going back to our formula, to our function, um we we're just gonna have to, oh sorry, I used x there but t here, so I'm going to use x here as well. Yeah, okay, so if we go look here, all we need to do is put this 6 pi into the bracket, so we're gonna have to rewrite that and then we can figure out what the angular frequency is. Okay, if we do that, let's do it the long way, a little bit of the long way. That's going to be 5.8, then sine of um pi over 6x plus pi over 6, right? Okay, so with this we can already say with confidence that your angular frequency is pi over 6, and this should be equal to 2 pi f, right? So from here we can now solve for the frequency. So let's just do it here now, the last bit. So pi over 6 equals 2 pi f. Pi cancels out. And then from there, f is equal to 1 over 12. That is the frequency. Okay, then of course from the frequency we can now relate the period is equal to 1 over the frequency. So from here the period is equal to 12, and that's our final answer. Okay,
So we multiplied 2 by 6 and then
yeah,
divided
because
it.
yes, so what happened
No,
here
we
is,
divided by 6.
yeah, so what we did is we put we're dividing both sides by 2 in this case, right?
Yeah.
So okay, so this 2 will
So it'll be
cancel
2
out.
over 6.
No, it will be 1/2 times 1/6. So I'll put it here, 1/2. I think I better get rid of that, times 1/6. Okay, and from there we get 1/12.
Oh, right. Right.
Okay,
Okay.
all right, so let's take a look. Okay, so I think that's clear. Let's take a look at number part B. Okay, um in this case we do
Yeah.
have an extra term plus b. I didn't quite put it in here yet, but let's just put it in there, plus b. Okay, I forgot what the plus b is. what it means, but in physics, because we don't really encounter it often.
Um,
I think it's just shifting it
yeah.
up or down. Yeah, if I'm not mistaken.
There was a formula for B.
Mm-hmm.
I think B was um,
All right, but either way, let's now put these values. Let's go to B part 1 and part 2, right? So either way, what matters here is we have 2 points given, and then we just put our value in. So let's put the formula in again. F of x is equal to 5.8 times pi over 6 times x plus 1 plus b. Okay, so we're given 2 points. We're given 2 points, maximum of 2, 21.8, and then the other point, so let's put that as max, and then the other point, a minimum of 8, 10.2. Okay, so all we have to do is
sorry, I
go ahead.
remembered. Sorry, that the time period is equal to 2 pi over B. I think that was the formula.
2 pi over b.
The time period, which we found.
All right. Okay. Hold on. Let me think about that particular thing. Okay. Actually, not so sure, but okay. Give me a moment to process this. Okay. No. That is actually the I think it's because of the way it's got presented before. Okay. Now, the b here is a constant in this particular case. All right. I think I better show you on. I think I better show you this here. So let's put the. Let's just put it in here in
So
Desmas real quick. Go ahead.
it's like an intercept instead of
Yeah.
something.
Okay.
Huh. Okay.
All right. 5.8. Let's just put it in here. Sine of I over 6 times there x plus 1 then plus okay. All right, so this is I'm gonna show it to you on the screen right now, so I'll also be sharing this here. Okay, where are you? Here. All right, so let me share this on screen. Stop share and share this Desmos. All right, now I'm also gonna share that. Shall I share that on the stream? Of course I should. Okay, hold on, just real quick. All right, so this is what it looks like right now without the b, without any. Add 3. What we're gonna do now is we are going to just put these values in here. So we're gonna do f of 2, and that's going to be equal to 21.8, and that's going to be equal to 5.8 sine of 6 pi. Sorry, pi over 6, right? Over 6 times x is 2, so that's gonna be 3 times 3, right? Plus b. And then similarly, if we put 8 in here, f of 8, this will be equal to 10 point, what was that? 10.2, right?
Not sure.
Okay,
Yeah,
hold on.
10.8.
10.2, yes, 10.2. 10.2, that's 21.8, right? So this is now equal to 5.8 sine of pi over 6, and then our 8 plus 1 is gonna be 9 here, then plus b. Okay, so all we're gonna do now is the subtraction. We're gonna subtract these two. Okay, so from here, what do? I'm going to subtract Um, 21.8 minus 10.2 is equal to 5.8. Well, if you look at this, basically the 5.8 is a common term, right? So all I'm gonna do now to do this
Yeah.
as a shortcut is this is gonna be 5.8 times, well, pi over 6 times 3 is gonna be pi over 2, right? Pi over 2. Then minus, what's this gonna be? This is gonna be 3 pi over 2 minus 3 pi over 2. Okay. Then plus b minus b. So they cancel out, right?
Yeah.
Oh, okay. Sorry. I have to say that this is sine. And this is also sine. Okay. Is there anything else we can find? Yeah. So, yeah, basically what we're gonna do here is we're gonna find this value first. So this is gonna be 0.6, 21 minus 11.6 here. Okay, and this is still gonna be 5.8 times this. What's sine of pi over 2? The sine of 90 degrees.
I
Sine of
forgot.
90 degrees is 1, right? And this sine of this is
Yeah.
gonna be minus -1. So that kind of works out, but we run into a problem. We get into the exact same thing, 11.6, right? Okay.
Yeah.
All right. So the problem now here is, I guess, no. Actually, we just did part 2, f of 6. Okay. 1.8
Mhm.
equals 5.8 plus b. There, we just found our b. So b will be equal to 21.8 minus 5.8. So that's going to be 21 minus 5. That's going to be 16. Okay. Now that we have our value of
That makes
b,
more sense.
yeah, yeah, I think this was easier, right? Now, just so you know, I'm doing this
Yeah.
without a marking scheme, so I'm doing this just like an exam. So basically, I think this is gonna be very similar to what you would be doing anyway. You're trying stuff out, right? Once,
Yeah.
all right, so that's gonna be fine as long as you're able to see something good. So once you figure out b, we just put f of 6 now. So f of 6,
Yeah.
let's solve for that. F of 6 will be equal to um 5.8 times sine of pi in this case plus 16. What's the sine of pi? 0. Okay.
Um, should it also be 1?
No. Remember in the unit
0.
circle? Remember on the unit circle? This is pi over 2. This is 3 pi over 2. This is 0 or 2 pi. And then this is pi. Right? And then
Right.
remember, right? And then so it's going to be 0. The y coordinates the sine,
Yeah.
right? So this is going to be 0. F of 6 is 16. Okay? All right.
Yeah.
All right, let's do the last one here. You have a second function. I'll take another screenshot. Okay, you have a second function given g of x. Okay. Find the value of p and the value of q on that function g. Hold on. Okay, I'll just put it here so we have a better view of the problem. Okay, you're also given that the function g passes through 2 points and the coordinates are given. Okay. Okay, here we go. So that's our second function g. P sine of that whole thing. And then function g passes through those 2 points. So it's gonna be the same thing here in C. We're gonna do g of 3 first. G of 3. Okay, our g of 3 will be equal to 2.5, and that will be equal to p sine of 2 pi over 9. Our x is again 3. 3 minus 3.75, it's going to be negative 0.75 or negative 3/4, right? Okay, plus
Yeah.
q. Similarly, we do the other one, g of 6. So g of 6 will be equal to 15.1, and that's equal to p sine of 2 pi over 9. Then 6 minus 3.75, that's 2.25. 2.25 in fraction form, improper fraction, is what? 9 over 4. Okay.
Yeah.
Okay. So from there, then plus q. Now, in this case, we don't, the technique we did earlier, we can now do that because we have two equations of two unknowns, right? So we're gonna do the subtraction of the two formulas here. So to get rid of q, so to speak, yeah? So we subtract this. So what do we get here? 15.1 minus 2.5 should be equal to p. The p can be factored out. It's gonna be sine of uh what's that gonna be? 2 over 4 is sine. That's gonna be 2 here. Then 3 over 9 is gonna be a 9 times 3 here. And there's gonna be a pi here, right? And there's a negative sign there. Plus q minus p times sine of, let's cancel stuff out, 99 cancel out, pi over 2 in this case. Okay, plus q again, minus sign here, right? So this q
Sine.
cancels out, and we're left with that's gonna be 15.1, 13.1, 13, 12.6. Okay, so this is 12.6, and that's gonna be left, you're gonna be left with p times, let's just factor p out straight away. What is that's gonna be sine of pi over 6, negative pi over 6, minus sine of pi over 2. Now these you can calculate straight away. So sine of pi over 2, again, pi over 2 is 1. So this is gonna be minus 1.
1.
Then pi over 6 is 180 divided by 6 to make it easier. So that's 30 degrees. Sine of 30 degrees.
It's like 1 over root 2 is,
It is 1/2. It is 1/2.
I think.
But it's got a negative, so minus 1/2,
Yeah.
right?
Yeah.
And then 12.6 is equal to this, p times this. So that's going to be 3/2. So let's just simplify this as 3 over 2 negative, right? And there we go. We just found p. So p is equal to 12.6 times 2/3. So this is going to give us 4.2. So that's going to give us negative, right? Forgot the negative there. So this is negative. So we're now left with negative 8.4. So we found our p. Okay. Then all we do now to find q is substitute that p into one of those equations and determine q. Okay. All right.
Okay.
Okay. Let's just do D. Find the value of x wherein the functions have the greatest difference. Okay. Okay, let's do this now. Where do we have the biggest difference for f of x and g of x? Okay. So let's just do that here. G of x. So let's do f of x minus g of x is maximum, right?
Yeah.
Okay. So you're gonna get that. Um, you're gonna get. Remember, because of the fact that these are periodic. That means you're really gonna have to look for a time wherein the difference is the biggest. Yeah, the time, right? Of course, the obvious way to do it, trial and error, that's going to be way too hard, way too long at least. Okay. So what we're gonna do here really
Yeah.
quick is we're gonna see how they more or less behave. So if f of x is behaving somewhat like that, and then g of x is behaving somewhat
Mhm.
like this, something like that, right? So where would you basically there will come a time wherein you have this and this, right? Or you can have this or this. So these would be your
Um,
possible answers, right? So where the peaks and the troughs meet. In other words, the technique here now is hold on. Do they have the same frequency? They do not. They do not have the same frequency, so it won't really work well. Yeah, because they don't have this.
maybe we could plot it.
Sorry, say that again, please.
Could we plot them on the GDC?
I think that would be the best because it's only 2 marks. It's not gonna be a really good idea to solve for this, right? So yeah, you
Yeah.
have to plot both of these functions onto your GDC. So that's the easiest thing to do, yeah? So plot in GDC.
Mhm.
Then look for these points wherein you have a maximum from X, so or from F, and then you have a minimum from G. Or the other way around and see which one's got the biggest ones. Okay. All right.
Okay.
Okay. So the math problems are done.
Yeah.
All right. Okay. Okay, before we go, I'm looking at the schedule here. According to this, we still have 5 lessons to schedule. Um, so yeah.
Right.
In this case, I'm gonna ask you now, what days would be best for you? I'm assuming Fridays and the weekends.
Probably the weekend.
Yeah.
Fridays, next week, no, but after that, yes.
Mm-hmm. All right.
The rest, the weekend, I think is the safest. And then if you can't over the weekend, I'll try to move it in the week.
Yeah, the weekend's fine.
But it's mostly
Mm-hmm. The weekend should be
okay.
fine. Yeah. All right. 6 p.m. Oh, okay. You said you do go home at 6. That's a bit too late for me here. So yeah, we can't really do weekdays anymore at the moment. At least until your
Yeah.
schedule clears up. Okay.
Yeah.
Uh.
It's mostly this month, and then next month I'll be more free after deadlines.
Oh, okay. All right. Grade 12. What are your deadlines right now? I'm assuming you have IAs and probably the extended essay.
Yeah, I mean, they were all supposed to be done, but I missed quite a lot of them. So I have to do those, and I have to do my applications and make my portfolio.
Right. Oh yeah, the portfolio as well. Correct. Um.
Mhm.
Okay. All right. I just have one question. How are your math and physics IAs? Done?
I'm actually really happy with them. My
Ah.
math is doing really well, and I'm planning to finish it today.
Mm-hmm.
And physics, I just redid my data last week, so I'm gonna extract the values and I'm gonna finish it.
All right. Okay. I don't think you need it.
Yeah.
I don't think you need my help on both of those counts, so we're good. I think. Yeah.
They're going, yeah, but thank you.
All right. Okay. So for that, then, okay. This is what I'll do. All the Thursday and Friday lessons for next week, I'll just move
Mhm.
them to some other days. Okay.
Okay,
All right.
thank you.
All right. And then the one yesterday. Are you sure you just want to give that away for free? I'm okay to reschedule that.
I feel really bad for wasting your time.
Okay. Don't
Yeah.
worry about wasting my time. Just so you know, don't worry
Mhm.
about it. this is a side gig for me, so it's fine with me. Okay.
Okay.
All right. So okay, I'll definitely reschedule those others, the ones for next week. All right.
Yeah.
Okay.
Thank you.
All right. I'll see you next. No, I'll see you tomorrow to continue with this. Okay.
Yeah.
All right. Bye bye now.
Okay.
Have a good evening, and I'll see you
Have a
tomorrow.
good evening. Bye bye. Thank you.
Bye bye. All right. So that's the end of the lesson. Yeah, we did a lot of math today. Well, two problems. Let's just go back here to the main. Right. So two big problems in math. Um, so if you found this useful, well, I think for the first problem we did earlier, I think I may have made an error. But again, I pointed this out. It really doesn't matter if you make an error or not in the math, in the calculator math section. Okay, um, it kind of matters because of course you want to get the best possible score, but remember that especially for the ones with more marks, you are not actually marked just for the final answer. You're marked as well for your solutions. And a lot of the time, if you made a solution with an incorrect number and you continued on with it, you will get marks for the working. You could get marks for a wrong answer that came from a wrong value previously, or we call that error carried forward. So when you have ECF or error carried forward, that's fine. You don't really need to worry about the final answers from there as well. Okay, it still depends on the paper and it still depends on the question. But basically, yeah, that's what happens. So of course, if there's anyone there who wants to correct me if I'm wrong with that, just let me know and I will correct myself if that's the case. Yeah. Uh anyway, I'm speaking about this with my experience as a math teacher, but not an IB math teacher because I don't really teach IB math. Okay. So if there are any corrections from what I've said, let me know. And I'm more than willing to correct myself in front of everybody. Okay. So with that, with tomorrow we'll be back. We'll do another stream tomorrow for physics. I'll probably post that on Instagram when we would be live. Okay. Um. Okay. I think we're good at the moment. So before we go, don't forget to like, share, and subscribe to the channel. We are on Facebook, YouTube, Instagram, TikTok, and Twitch when we go live. So with that, I bid you all a good morning, good day, good afternoon, good evening, good night, wherever you are in the world. Stay freaky, everybody. Bye bye now.